So for those of you who were absent or those of you who want to recap, I'm just going to do a short run through what ions are. I'm going to take you through some of the notes, but not all of them. I don't want to go into it in great detail here, but I do just want to do an overview, especially for those of you who were absent. So we looked at what ions were, and we looked at how they are charged particles. So if you're asked in an exam what an ion is, you would simply say it's a charged particle. And ions are formed when an atom either loses or gains one or more electrons. So we looked at how atoms, they have the same number of protons and electrons, and as a result their charges cancel out, and overall an atom has a charge of 0. But ions are formed when we either lose or gain electrons, and that means overall we do have a charge because they don't exactly cancel each other out. Okay, so it says here the charge is no longer 0 since the number of electrons, which have a charge of -1, has changed, but the number of protons, which has a charge of +1, remains the same. So an atom will never change its number of protons, but it can change the number of electrons that it has, and that's what happens when atoms react. Now, it's a little bit confusing to get your head around at the start, but hopefully you will see that this makes sense. It sounds a wee bit counterintuitive, it sounds like I'm saying something that's wrong, but you just got to think about it twice, but don't overthink it, don't overcomplicate it. Okay, so what happens is when an atom loses electrons, it will become a positively charged ion because there's now more protons, which have positive charges, than electrons. So think about it, you are losing electrons which have negative charges. So if you're losing a negative charge, overall you will become positive. It's like minusing a minus number. That's positive. So let's look at an example. Let's look at the example of lithium. So lithium, you can see, has an atomic number of 3. So as an atom, it has 3 protons and it has 3 electrons. So overall, we have a charge of +3 from our protons, and we have a charge of -3 from our electrons. Those obviously cancel each other out, and we're left with a charge of 0. But what happens when lithium reacts, or when lithium forms an ion, is that it loses 1 electron. It's lost 1 electron, but the number of protons stays the same. So it still has 3 protons, but now it only has 2 electrons. So let's think of our charges. We still have +3 from our protons, but now we only have -2 from our electrons. So what is the charge overall? Well, +3 minus 2 is a total of +1, okay, +1. So we can see how we have lost an electron, but the charge on my ion, the charge on my particle overall, is now +1. It's no longer an atom because it doesn't have the same number of protons and electrons. It's now called an ion with a charge of +1. When we're writing the formula of the ion, because it's +1, we don't include the 1 in the formula, and so it's just Li+. The last thing then to note about positive ions is that you need to learn the general name for a positive ion, and it's called a cation. It's called a cation. Sometimes I think of that T in cation being like a plus sign. Okay, so positive ion is called a cation. Let's now move on to what happens when atoms gain electrons. So if an atom gains electrons, it will become a negatively charged ion. Again, that seems like opposite thinking, but again, remember, you're taking on extra negative charges, and so that means that it'll become negative. It's you adding on negative charges, and so that is negative overall. Let's look at an example to prove that. So let's look at the example of fluorine, which has an atomic number of 9, which means there are 9 protons. It also means there are 9 electrons. So if we think of the charges in this atom, well, there's going to be a total charge of +9 from the protons and -9 from the electrons. That gives us an overall charge of 0, because the 9 positive charges from the protons cancel out with the 9 negative charges from the electrons. But when fluorine reacts, or when it forms an ion, it gains 1 electron. So if it gains 1 electron, the number of protons doesn't change, so it's still going to be 9 protons. But now we're going to have 10 electrons. So let's think of our charges now. It's going to be plus 9 from the protons, but it's going to be minus 10 from the electrons because I now have 10 of them. 9 minus 10 gives us a charge overall of minus 1. So you can see how I've gained an electron, but my charge has become minus 1. It's become negatively charged. And when we're writing the formula of this ion, it's the F minus ion. Again, if it's a charge of minus 1 or plus 1, we don't include the 1 in the formula, but we do include it in the charge. And then generally a negative ion is what we call an anion. And again, to help you remember this, I would think of that N as standing for negative. So a negative ion is an anion. Okay, and just a quick general note is that metals tend to lose electrons, and this will come in handy in our bonding topic. Metals tend to lose electrons, and when we lose electrons, remember, we become positively charged because we're losing negative charges. So overall, we have a positive charge. What we said is that positively charged ions are called cations. Thinking about that T as a plus sign. Then non-metals do the opposite. They tend to gain electrons, and so they will be negatively charged. And negatively charged ions are given the general term anions. And this is a really important point, that atoms tend to lose or gain electrons in order to achieve a full outer shell. Okay, so ions will tend to have full outer shells. So if you're asked to draw the electronic structure of an ion, it's a good thing to check at the end that your ion has a full outer shell. If it doesn't, more than likely you have done something wrong. What we also talked about in class, which I will mention in brief detail here, is that the charge of an ion is actually linked to its group number. So what we'll look at in a later topic is that the group number is equal to the number of electrons in the outer shell. So group number 1 have 1 electron in their outer shell. Group number 5 have 5 electrons in their outer shell. And so atoms within a group will want to do the same thing in terms of electrons in order to get a full outer shell. So we talked about this more in detail, and it is in your notes, so make sure that that is filled in. But if we think about group 1 elements, first of all, they all have 1 electron in their outer shell. So lithium would be 2, 1. Sodium is 2, 8, 1. Potassium is 2, 8, 8, 1. And the list goes on. So what that means is that the group 1 elements all have 1 electron in their outer shell. So in order to get a full outer shell, they all have to lose 1 electron. And when we lose 1 electron, we end up with a charge of plus 1. Group 2, they all have 2 electrons in their outer shell, so they all have to lose 2 electrons to get a full outer shell. So they have plus 2. So the ions in group 2, they all form ions with a charge of plus 2. Group 3, they all have 3 electrons in their outer shell, so they have to lose 3 electrons and have a charge of plus 3. You should be writing these charges on your periodic table if you haven't already done so. Group 5 then, they have 5 electrons in their outer shell, and what that means is to get a full outer shell they want to gain 3 to get up to 8 electrons. So if they gain 3 electrons, the ions that they form will have a charge of minus 3. Group 6 have 6 electrons in their outer shell, and so they gain 2 electrons to form ions with a charge of minus 2. And group 7, they have 7 electrons in their outer shell, and so need to gain 1 electron, so their ions have a charge of minus 1. Now we left group 4 out because they tend not to form ions, well, the ones near the top of the group anyway, they tend to share electrons. We'll come back to that in a later topic. And group 0 or group 8, they already have a full outer shell, so they do not form ions either. So knowing the charges that the atoms within a certain group form, that really helps us when we're drawing our electronic structure. So let's do a little bit of practice of drawing the electronic structure and writing the electronic configuration of ions. Essentially it's just in the same way, following the same rules, but obviously we're adding or removing electrons. if the electrons are added on, so if we're gaining electrons, the extra electrons are added into the outer shell in the same order as they would with the atoms. And if our electrons are being removed, in other words, if we're losing electrons, then they're removed in the reverse order. So in other words, we remove from the outer shell first. And then at the end, remember to check, does your ion have a full outer shell? So let's look at the example of magnesium forming its ion. And we'll start from the atom first of all, and then see what happens with the ion. So magnesium has an atomic number of 12 and a relative atomic mass of 24. We're really only interested in the number of electrons, and in an atom the number of electrons is equal to the atomic number. So we have 12 electrons. Let's draw the electronic structure of the atom. So we have our magnesium, there's the nucleus, and here's the first shell. We have 2 electrons in our first shell. The second shell can fit up to 8, and remember we fill north, east, south and west, and then if we need to go back round, we do. That shell is now full, but I have 2 more electrons, so I need to draw another shell. One goes at the top and one at the side. So this is the magnesium atom, and you can see it has the configuration 2, 8, 2, which corresponds to its group number. Magnesium is in group 2, so it has 2 electrons in its outer shell. So when magnesium forms an ion, it wants to get a full outer shell, and so what it's going to do is it's going to lose its 2 outer electrons. So it essentially wants to lose this electron and this electron. Let's draw the electronic structure of what we are left with. So we now only have 10 electrons, or 2 electrons have been removed from the outer shell. My atom is, well, it's no longer an atom, it's now an ion, and so it no longer has a charge of 0. It has a charge now that it's an ion. It's lost 2 electrons, so that must mean the charge on the ion is now +2. Remember, losing electrons makes your ion become positive, because I now have more protons than electrons. This is what we call the magnesium ion. How we write the formula is actually the number comes first. So it's actually Mg2+ rather than Mg+2. So you need to get into the habit of writing that correctly. So it's the Mg2+ ion. And now we can see our configuration is 2, 8. And you can see that yes, it fits the criteria that it has a full outer shell. So that's how you might draw the electronic structure of your ions starting from the atom. But there's a slightly quicker way to do it. So over on the next page we have 2 more examples, and we'll do it the quick way. The quicker way is to work out, well, how many electrons does the ion have, rather than starting from the atom, okay, and drawing that out. So we can see here we've got the chloride ion. It's changed its ending to IDE because it's negative now. What we can see is the chloride ion has a charge of minus, or in other words, -1. So what I want to think about is what's happened to my atom. Why has it now got a charge of -1? Well, it must have gained 1 electron. Must have gained 1 electron. So let's have a think what that means for my number of electrons. Well, how many electrons did chlorine have to start with? Well, look it up in the periodic table. Your atomic number of chlorine is 17. So it had 17 electrons. It's now gained 1. And so it has 18 electrons. And simply then you draw your electronic structure for your ion containing 18 electrons. So you have your chlorine nucleus, then you have your first shell with 2 electrons, you then have your second shell with 8 electrons. That is full, so we need a third shell, and it also has 8 electrons. So there is our ion with 18 electrons. We must show the charge, so put square brackets around your ion. This time the charge is -1. Overall we call this the chloride ion, the Cl- ion. Remember, in the formula we don't need to include any 1s if we have them, so we don't write Cl-1, it's just Cl-, and the configuration is 288. Let's look at one more example, and then over to you to do some practice. Let's look at the aluminium ion. So what has happened to my aluminium? It's got a charge of 3 plus, which must mean that it has lost 3 electrons. It has lost 3 electrons. What does that mean for the number of electrons in total? Well, aluminium in the periodic table has a relative atomic mass of 27 and an atomic number of 13. So it started with 13, I've lost 3, so I must have 10 electrons now. So again, just draw your structure, your nucleus, first shell with 2 electrons, second shell with 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Put square brackets around it to show your charge. The charge is plus 3, remember the sign comes first, and then when we're writing the formula, the number comes first, so it's Al 3 plus. And your configuration is 2, 8. And again, you can see that the outer shell is full. So the easier way to do these is have a think from the charge, what has happened to your atom in terms of electrons, has it lost or gained electrons and how many? Work out how many electrons it now has and then draw your electronic structure, but remember to include your charge. What you should do now is practice drawing out the electronic structure of these ions in your exercise book and just set them out the way we have just been doing them. So for number 1, you've got Li plus. First of all, think about what has happened in terms of the electrons. So the charge is plus. That must mean that it has lost 1 electron. Okay, remember it's opposite essentially to the sign. So lithium, if you look it up in the periodic table, has an atomic number of 3. It's now lost 1, so it has 2 electrons. And draw your electronic structure from there. Remember to include your square brackets and your charge. So 1 to 5 are fairly straightforward, you've given your charge. Number 6 to 10, you're only given the name of the ion, but remember, get the charge from your periodic table, PT periodic table. So for example, magnesium is in group 2, so they all form ions with a charge of plus 2. Okay, so that's the charge on it, so it has lost 2 electrons and go from there. Okay, so look to the top of the group, you should have written your charges on. That gives you the charge of the ion, and then draw your electronic structure from there.